Well, hello and welcome to Math Blossoms, where growing in mathematics is natural. I am the teacher, Miss G, and for today's math topic, we are going to learn how to estimate irrational numbers or non-perfect square roots. We're going to try to do it without a calculator, and then we're going to check ourselves with a calculator so that you can kind of get a better understanding of what we're doing. All right, let's get started. The question for today's lesson is not working. Hang on. There we go. How do I estimate or approximate non-perfect square roots without using a calculator and with using a calculator? We are going to show you both in this video. It should not be too long of a video. The first answer that we have here is to write down the perfect square roots 1 through 12. If you know 1 through 15, that might help. Generally at this level, you typically won't do, huge numbers with this without a calculator. But if you're having to do like smaller numbers, like 12 times 12 is 144, for instance, that does help to know your multiplication tables and your perfect square roots. And we will go over that in just a moment as well. So write down your perfect square roots and then find out which two perfect square roots the non-perfect square root falls in between. Then next, we would determine which perfect square root it is closer to before making the estimate. And then, of course, we would check ourselves using the calculator at the end. So I know that's a lot, so I'm just going to explain it by showing it. So here is our perfect square roots. Remember, perfect square roots are when you just say, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so forth. And we just have those all the way until, 12 times 12, which is 44. We're going to start off with having a number line because once we know the estimate of the non-perfect square root, we're going to try to plot it in the correct location on the number line. Okay. One thing to take note of whenever we're plotting things on a number line is that let me go ahead and get a pen out here. Let's start with blue. That the midway point between each number is going to be a 0.5. For instance, between 1 and 2 here would be, 1.5. which is exactly halfway between. And then of course, between 2 and 3 right here would be 2.5. And so forth. If you didn't know that was the halfway point, like if we were dividing this up into 10 sections, you would have, 1.1, 1.2, 1.3, 1.4, and then of course 1.5. And then we have 1.6, 1.7, 1.8, 1.9, and then 2. Okay, so that's how it would kind of look if you were dividing it up into 10 sections. And that's basically what we're trying to do, is get to the nearest tenths place when we're estimating these non-perfect square roots. Let's go ahead and erase some of these lines. We'll leave the halfway point there just to remind us that that is the halfway point. Let me put it back there because I accidentally erased it. Okay, so now we have the square root of 8. So the first question is, what two perfect square roots is the square root of 8 going to fall between? And if you start at the top and go down, as you can see, the square root of 4 and the square root of 9, the square root of 8 is going to fall in between those two. Okay, so it's going to fall somewhere in there. So because of that, I'm just going to go ahead and jot down those two. Like before the square root of 8, we have the square root of 4. And after the square root of 8, we have the next one, the next perfect square up, which is the square root of 9. And then if you think about it, the square root of 4 is a 2. And the square root of 9 is a 3. So basically we already know, I just made an extra mark here. Let me erase that. The square root of 8 is going to fall between 2 and 3. So we're talking about this little section up here, but we have to think about it. Which one is it closer to? Is it closer to the 2 or is it closer to the 3? So let's look here. 8 and 4, the distance between them is 4, right? 8 and 4, square root of 8 and square root of 4. So this distance between 8 and 4 here is 4. But the distance here between 8 and 9 is 1, right? Because you only have to add 1 to 8 to get 9. So clearly, it looks like the 8 is going to be much closer to the square root of 9 than it's going to be to the square root of 4. Okay, so in that case, when we're guessing or estimating the square root, and we know it's a number between 2 and 3, we're not going to guess anything on this side of the halfway point because we know that the square root of 8 is closer to the square root of 9, which is the 3 here. So you might want to guess a point like maybe somewhere around here, like maybe 2.8 or 2.9, something that's really close to 3, okay? And then check ourselves, like how close are we? We guessed 2.8, it might be 2.9. It's going to be close to that. So let's go to our Desmos calculator, which I have pulled up here. And we're just going to put in the square root of 8, and what do we get? We get 2.82. And because the 2 here in the hundredths place is not a 5 or more, we don't have to round up this 8. So we exactly guessed correctly that it was 2.8, and we just checked ourselves with the calculator. So good job, everybody. So now let's go to the next one. Whoop, went too far out. And we are still on this slide. I'm going to erase my writing. Okay, so let's do the square root of 34 next. Okay, so the square root of 34, we'll do it in a different color. We'll use orange this time. Okay, what two perfect square roots does the square root of 34 equal? Or it falls between. So if you look at over here on, why is that there? I don't know why that's there. It should not be there. Let me try that again. There we go. I don't know why that was there. Oh, here we go. Da, da, da. Okay. Back here, back here. Okay, so we already did the square root of 8, and we knew it was like around here at the 2.8 mark. And the square root of 34, clearly it goes between the 25 and the 36 here, right? The square root of 34. So square root of 25 is before the 34, and the square root of 36 is after the 34. And so we know that the square root of 25 is a 5. 5 times 5 is 25. And the square root of 36 is 6. 6 times 6 is 36. So we're talking about a number, between 5 and 6, which would be right in this part of the number line. Now, is 34 closer to 25, or is it closer to 36? 34 is only 2 away. Like if I add 2 to 34, I'm going to get 36. And then over here, I would have to add 9 to 25 to get the 34. So it's much closer to the 36 than it is the 25, which means it's much closer to 6 here on the number line. So once again, that looks like it could be 5.8. And if this is the halfway point at 5.5, 5.8 would be like somewhere around here. 5.8. And we can mark that with the actual number we're trying to plot, which is the square root of 34. Okay, let's check ourselves in the Desmos calculator again. This time we have the square root of 34. So we're going to go here. We're going to change this to a 34. And we have 5.83, and this 3 is not going to make us round that up. So 5.8 was the correct guess. So again, I'm trying to show you how to do this without a calculator so that you can kind of get an idea of what this number represents. When you find a square root, you are between two perfect square roots. When you're finding the square root of a non-perfect square root. Now, remember that perfect square roots are rational numbers, and non-perfect square roots, the ones that have the decimals that go on forever, they're non-terminating, and they don't repeat. Those are the irrational ones. So back to, oops, I keep closing it out. Don't mean to do that. All right, now we're going to try to do 73. And 73 is between the perfect squares of 64 and 81. So we're talking about right in here would be about where the square root of 73 would be. And so if it is the square root of 64 over here and the square root of 81 over here, that means it's going to be between 8 and 9, because the square root of 64 is 8 and the square root of 81 is 9. So we're talking about right in this area of the number line. And now we have to think about, how close is 64 to 73? Well, it's going to be 9. Like if I add 9 to 64, I'm going to get 73. And then how close is 73 to 81? And that would be 8. I would have to add 8 to 73 to get 81. So if you notice, 73 is almost halfway between these two, because it's almost the same distance from the 73. The 64 is only 9 away and the 81 is only 8 away. So it's slightly closer to the 81 than it is the square root of 64, which is 8. So I'm thinking it's going to be near the halfway point, but maybe just slightly ahead of it. So a good guess is the halfway point, to be honest with you. So let's say 8.5. Let's see if that is a good guess. If it's not 8.5, I would think that it might be maybe 8.6, somewhere in that area. Because it is almost halfway between the two exactly. So let's go ahead and check on our Desmos calculator and see if 8.5 or 8.6 is close to what the square root of 73 is. So I'm going here. I'm going to change this to 73. And I'm getting 8.6. So yes, 8.6 is the answer, which I said 8.5, but actually 8.6 is a better answer. But we were close. We were saying it was 8.5 or 8.6. So we were very close on that one. And so now we are at the last example I was going to show you, which was the square root of 84. So once again, we're going to find the two perfect square roots that surround this non-perfect square root of 84. And that would be between 9 and 10 right here. Square root of 81 and the square root of 100. 84 would fall between those two. So if I have the square root of 81 here, and I have the square root of 100 here, then I know that the square root of 84 is going to be, between 9 and 10 somewhere, which is somewhere in this area of the number line here. And if you look at this, 84 is only 3 away from 81, but it's like 16 away from 100. So it's much closer to the 81 than it is the 100. So since that's the case, and 9.5 would be the halfway point, I'm thinking it's going to be closer to the 9 here, and it's going to be maybe 9.1, maybe 9.2, somewhere in here. I'll guess 9.1. And if it's not 9.1, it might be 9.2. Let's check it out in our calculator and see what we get. All right, so Desmos, we're going to use this, and we're going to hit 84. And it's 9.16. Now this 6 means I do need to round that 1 up to a 2 if I'm rounding this to the nearest tenth. So 9.2 is actually the best answer when you round that non-perfect square root or that irrational number. So that being said, hopefully this oops, I did not mean to do that. Now that we found some using our, without using the calculator, we did some really good estimates and got really close. And then we double checked ourselves with the calculator. So great job, y'all. So here's some things to remember, that when you're estimating irrational non-perfect square roots without a calculator, it is best to know to write down some of the perfect squares first and try to figure out which two perfect squares that your non-perfect square root falls in between. And remember that the halfway point between the two whole numbers, or the two integers on your number line, will be 0.5, like 8.5 or 9.5 or 7.5. And always remember to check yourself with a calculator if one is available, just to be sure your estimate is correct. And that does it for estimating non-perfect square roots using a number line and trying to do it without a calculator. Just knowing your perfect square roots really does help with that. So you can grow in mathematics, definitely. So keep trying to do these kinds of things before your quiz and test coming up. And hopefully you'll be, this will be easy for you after a while. So it's time for me to say it was lovely teaching you math today. Bye-bye.